Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to compose linear and quadratic functions. All right, so let's go ahead and take a look at the instructions for the examples. We're to perform the specified operations. Okay, so number one, let's say we have g of a equals negative 2a plus 3, and h of a equals 4a plus 4. All right, and we have to find g composed with h of a. All right, to get us started, let's take a look at the steps that will be guiding our problem-solving process for the procedure of composing functions. So the steps are as follows. What you do first, number one, is you place the parent function, place the parent, and then step two, you get the parent prepped for substitution, and then three, you plug in the inner function into the parent function, and then number four, you just PEMDAS it. Okay? So place parent prep, plug in, and PEMDAS. So let's go ahead and get started with this example. We're going to use the steps outlined here to solve the problem. So we're looking for a g of h of a. So which of these two is the parent function? That's the one we're going to place first, okay? So remember that the parent function is one on the outer, because we have a function on the outer and we have a function on the inner. So think about the inner function as a baby, okay? And the outer function as a parent. So we're going to place the parent function, which is g of a first. So negative 2a plus 3. All right, so that's the parent function. Let's just put the inner function on the side. Let's bring it down. Now we're going to get the parent function prepped. Okay, what does that look like? We're going to prep it with parentheses. Take out all the variables and replace them with parentheses, all right? So we're going to have g of a, g parentheses, take the a out. And then on the right side, negative 2. Now, on the right side, when you're taking away the parentheses, take a look at the input function, the inner function, and see how big it is. It's a binomial, right? So we're going to put a parenthesis that's sufficiently large to accommodate it, plus 3. All right, so this is the parent placed, and we'll put the baby next to it. And then this is the parent getting prepped. Now what we're going to do is we're going to take the inner function, all right, and we're going to take the name of the inner function, and we're going to place it in the left side, right there. And then we'll take the value of the inner function, and guess what? We're going to place it in all the parentheses on the right. All right, when we carry out that substitution, we're going to have g of, the name of the inner function is h of a, so the name goes on the left, so let's put it in blue so you can see it. G of h of a, all right, and then on the right side, the value of the input function is what goes in the parentheses on the right in all the spots that you had prepped. So times 4a plus 4. Okay? So let's pause for a second and take a look at what we just did. All we just did is we replaced all the a's with the value of the input function on the right side of the parent function. Okay? So that's how we have this right here. If you have any questions, specify it in the comment section below, and we'll be more than glad to assist you. All right? So now that we have it this far, we're now going to PEMDAS this, okay? Basically using order of operations to simplify our algebraic expression on the right. So you take a look in the parentheses, there's nothing to be simplified, okay? So we have a multiplication and an addition here. So we need to do the multiplication first to get rid of this parentheses. So we're going to distribute negative 2 across both terms. Don't forget the sign now. So when you distribute the negative 2, you're going to have g of h of a is equal to negative 8a plus 8 plus sorry, not plus 8. Minus times plus is minus, so minus 8. So I want to be careful with that. Minus 8 plus 3. All right? So to finish this off, we're just going to add and subtract, combine like terms. These two can be combined, they're constants. So you have g of h of a is equal to negative 8a minus 5. There goes your answer for question number 1. All right, let's take a look at question number 2. So number 1, we had the composition of two linear functions. Number 2, how about we have a situation where we have the composition of a quadratic binomial and a linear function. All right, so what's the result going to be here? So in this case, let's say we want to find g of h of a. All right, okay, let's do it. So first things first, we have the steps outlined here. We're going to place the parent function. So the one on the outside, or the one that comes first, is the parent, or the outer function. All right, so the outer function is the parent function, and then the input function, or the inner function, is the one that goes in. All right, so let's place the parent. The parent function is g of a, which is negative 3a squared plus a. Okay, so we place the parent, and then let's get it prepped, clear out the parentheses. All right, the name of the input function goes to there, and then the value is going to go on the right. So we have a linear binomial. So let's make the parentheses sufficient. Okay, so you see how we took out that a and replaced it with parentheses. And we have another a, and we were going to replace that with parentheses too. In the first example, we had only one variable. That's why we had one parenthesis for that. Here we have the variable occurs twice on the right side, so we have two parentheses to accommodate for double substitution. Okay? All right, so there goes the parents. Let's put the baby right next to the parents. So h of a is 4a minus 4. So the name of the inner function, or the baby function, that goes to the left side, right into the name of the parent function, and then the value of the inner function, or baby function, gets substituted in two spots, right? It goes right here, we have the a squared, and it also goes right here, we have the a. So that gives us g of, instead of g of a, g of the name of the input function, which is h of a. All right, equals negative 3. Now we're going to put the value of the input function, inner function, in both spots. So we have 4a minus 4. Don't forget that square, quantity square, plus, and then we have 4a minus 4. Okay, so now just PEMDAS this to simplify. So in the first term, we have a multiplication and an exponent. So which one do you do first? For PEMDAS, you do the exponent first, right? So we're going to square this quantity. So it's negative 3. And then it's 4a minus 4 times 4a minus 4. Plus, and then we have 4a minus 4 here. So now let's multiply this completely. So we're still dealing with this square right here. So we're just going to FOIL it out. First, 16a squared minus first outer plus 16a inner minus 16a last plus 16 plus 4a minus 4. All right, we're still on the PEMDAS track, so we still have to finish off with the parentheses before we multiply the negative 3, okay? So if we do that, we're going to have negative 3 times 16a squared. So combine this middle term, you have negative 32a plus 16 plus 4a minus 4, okay? So now using PEMDAS, we're going to multiply first before we add like terms. All right, so let's go ahead and multiply. Negative 3 across all these terms. We have negative 48a squared minus 96a minus 48. Okay, that's plus 4a minus 4. So let's simplify further. Combine like terms. We have negative 48a squared. And then when you combine 96, just a quick correction here. So minus 3 times 32 is plus. So this is plus 96. Okay, good. All right, so when we combine 96 plus 96 and plus 4a, if you combine them together, you get 100a, right? And then when you combine negative 48 and negative 4, you get negative 52. So just remember when you're distributing here, you take in both signs to distribute to every term. So that's why this becomes a negative. And then that one right here, minus times minus is a plus, right? And then distribute to the last one. And that one, minus times plus is a minus. So ladies and gentlemen, this is what your final answer is. G of h of a, composition of a quadratic and a linear function. Alrighty, ladies and gentlemen, here are 4 practice problems for you to try out. Go ahead and pause the video presentation at this time. Try out these problems. When you're done, we'll reveal what the correct answers are for you to check your work. Alrighty, welcome back. So let's take a look at the solutions to the problems. The answer to question number 1, g of f of x is negative 9x minus 4. For number 2, f of g of a is 4a plus 2. And then for number 3, g of h of x is negative 32x squared plus 64x minus 36. And then the last but not the least, g of f of n equals 40n squared plus 22n plus 28. All right? So how well did you do on this practice problems? Let us know in the comment section below. If you also have any questions, specify it, and we'll be glad to assist you. Thanks so much for taking the time to watch this presentation. Don't forget to support our channels with your subscriptions, likes, and thumbs up. If you have any questions, as indicated earlier, just let us know. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a fantastic day. Goodbye.